Question 14, we're told that the pressure P is inversely proportional to the square root of the height h at which it is flying. So if P is inversely proportional to the square root of h, then it's proportional to 1 over the square root of h. If that is true, then we can write P is equal to k over the square root of h for some k constant. Okay, so k is a constant that we're going to look for now. So we're going to use what it tells us in the question. So it tells us that at a height of 25, the pressure is 1.44. So if we substitute 1.44 in for the pressure, that's equal to k over the square root of 25. So 1.44 is equal to k over 5, which means to find k, we just do 1.44 multiplied by 5, and that will give us 7.2. That means we can write P as 7.2 divided by the square root of h. So that was part A. We now want to look at part B. So part B asks us to find the pressure at the height of 36. So the pressure will be 7.2 divided by the square root of 36, which is just 7.2 divided by 6, which will come out as 1.2. Part C then is going to ask us to find the height the balloon will be flying when the pressure is 1.6. So this time our P is 1.6, and we're going to have 7.2 divided by the square root of h. So we want to multiply by the square root of h to get rid of the fraction. So we're going to have 1.6 multiplied by the square root of h is equal to 7.2. So the square root of h will be 7.2 divided by 1.6. The square root of h will give us 4.5. In order to find h then, we have to take 4.5 and square it, which will give us 20.25 meters. For the last part, for part D, it says if the height quadruples, so if it becomes 4 times greater, what effect is that going to have on the pressure? So if the height quadruples, okay, then that means the square root of 4 is 2. So we're going to be dividing by 2, which means the pressure is going to half. So for part D, all we have to say is the pressure is going to half, okay, and that is because we are dividing by the square root of 4. And so that's dividing by 2, which will mean that we're halving the pressure.